Now take another example, same way. So the open loop transfer function is given like this: g of s is equal to k upon s into 1 plus st1 1 plus st2. Now this transfer function is a type 1 transfer function and there are 3 poles, therefore the order is 3. Then what we can directly say from this, my starting angle is minus 90, ending angle is minus 270, because type 1, so minus 90 into p naught, so 90 degrees. The order is 3, so phi infinity is minus 90 into total number of poles, so that is minus 270. So magnitude also we can say directly without writing the magnitude phase angle expressions. What will be the magnitude? It is a type 1 system. Whenever you have type 1 system, the magnitude, starting magnitude is infinity and ending magnitude is 0. So all the cases ending magnitude we are getting 0 for minimum phase transfer function without zeros. Now I can tabulate that. So once of the table like this, then how to plot it? What is the starting point? Magnitude is infinity, phase angle minus 90 degrees. So we have minus 90 degrees line. Assume this is the infinity, that is the point. And where we need to locate the point? Either we need to locate the point in this coordinate or this coordinate. So we need to locate only in this coordinate, because my phase angles vary minus 90 to minus 270. Since there are no zeros, there is no chance of having phase angle less than minus 90 degrees. That means minus 89, minus 88, it is not possible because there are no zeros at all. So minus 90 to minus, so in this coordinate I need to locate the point. This is one point. Now, so what is the ending? Ending is magnitude wise 0. But when it is going to approaching to 0, then at which line it need to touch? So it needs to touch minus 270 degrees. So this is what the starting. While it is reaching to infinity, this is what the line is. So how can you draw this? So I can take like this and I can plot like this. This is my polar plot for the transfer function given k by s into 1 plus st1 1 plus st2. Then again, once the polar plot is available, as I said, the shape is not important, only the critical points are important. So in this case, my polar plot is crossing minus 180 degrees line. So what is that point? We know that whenever you have minus 180 degrees line, then we need to keen on that, because minus 180 degrees line is very important line, is one of the reference line in phase plot in the body plot. Therefore in stability analysis this is very important, minus 180 degrees line. Now it is touching the minus 180 degrees line. So find out what will be the point. Then it is very simple. Take the phase angle expression, equate it to minus 180 degrees. So when you equate minus 180 degrees, in this case what is the phase angle expression? Minus 90 minus tan inverse omega t1 minus tan inverse omega t2 is minus 180 degrees. So if you take all negatives cancel, then 90 if you take other side, then tan inverse omega t1 plus tan inverse omega t2 is 90 degrees. This is just similar to the previous case. In the previous case, we equated the phase angle to minus 90 degrees, where the phase angle equation was tan inverse omega t1 plus tan inverse omega t2 is 90 degrees. And in this case also we are getting the same thing. So the same way we can find out the omega value. The omega is, we have 1 over root t1 t2. So this is the frequency. Now this frequency I can call it as phase crossover frequency, because at this frequency the phase angle of gh of j omega is equal to minus 180 degrees. Right, so once omega pc is available, you can substitute in the magnitude, we can get the mpc value. So we have the magnitude expression, it is k by omega under root 1 plus omega square t1 square under root 1 plus omega square t2 square. In place of omega, substitute this, then you will be getting the magnitude value. That magnitude we already say it is called mpc. So what you will be getting mpc? We have k into t1 t2 by t1 plus t2. So this is what the magnitude is. And also we can easily find out, when you look at the polar plot is like this, and this is the magnitude where it is intersecting. And also what is the maximum possible of the magnitude? What is the maximum possible of the magnitude? The maximum possible of the magnitude is going to be t1 plus t2. So the distance from this axis to this maximum possible point is t1 plus t2. So these are the points which we can calculate. There is another way to get MPC value and omega PC value. So how can you do that? Let us take the GH of j omega and rationalize the transfer function. So once you rationalize it, then we can have a separate real part and separate imaginary part. Now we know that the polar plot, this minus 180 degrees line is nothing but at that line we will have a point. That point will be a real point when you convert into real and imaginary. Any point on the negative real axis will have zero imaginary part. Any point on the imaginary axis will have zero real part. Therefore, when I say there is a point on the negative real axis, imaginary part should be 0. So in the expression we have imaginary part, equate the imaginary part to 0. So when you rationalize, this is what you will be getting. We have real part plus j imaginary part. Then take the imaginary part here and equate it to 0. When you equate 0, then you will be getting it as again same value, that is omega pc. So 1 over root t1 t2. And take this, substitute in the real, then you will be getting the point. So that point will be the minus, because when I say real, it is a negative real axis. When I say real, so you need to take the negative or positive. When I say the magnitude will have all this positive. So in the previous case it was the magnitude MPC, in this case the real, that is minus k t1 t2 by t1 plus t2. So this way we can find out what is MPC and omega PC, then we can analyze the system. Let us take another transfer function where g of s is equal to 1 by s, which means we have only one pole at the origin. So one pole at the origin transfer function is 1 divided by s. So we can write it as g of j omega is 1 by j omega, the magnitude is 1 by omega, the phase angle is minus 90 degrees. So the magnitude is 1 by omega, as omega is varying, the magnitude is varying, but the phase angle is going to be minus 90 degrees only, which means my phase plot is always on the minus 90 degrees. Then what will be the direction? The direction is, we know when omega is the denominator, so therefore when omega is 0 starting, then it is going to be infinity, the magnitude. So it is starting from the infinity. When omega is infinity, the magnitude is going to be 0. Therefore the starting point m is infinity. Then it is on the minus 90 degrees line and it is reaching to 0 with magnitude is 0 and also phase angle is minus 90 degrees. Similarly, we can also take gh of s is equal to 1 by s square. Means there are two poles, it's a double pole transfer function. Again same thing, when you take the magnitude, it is 1 by omega square, the phase angle is minus 180 degrees. So minus 180 degrees is this line. So the polar plot is always on the minus 180 degrees line. And what will be the starting? We know it is 1 by omega square. When omega is 0, the magnitude is infinity. So infinity, when omega is infinity, the magnitude is going to be 0. So from infinity to 0, it is on the minus 180 degrees line. Similarly, for 1 by s cube also we can write, whenever you have 3 poles will be on this line. So for 4 poles on this line. So this way we can easily sketch the polar plot. If there are no zeros, then the transfer function is minimum phase transfer function.